This is the second video on 5.1, Intro to Quadratics. I'm going to try something a little bit different. I think kids are still playing a ridiculous game in the background. That's fine. Hopefully it's not too distracting. I'm going to try to write directly on the page here and zoom in. See if that works. A little more. All right. So here's the last one. Ready to give this a shot. I've got my coffee here. I don't know if you can tell. It's a nice birthday present. This appears to be a grizzly bear playing a guitar. Pretty awesome. All right, so now let's go ahead and fill this out. Let's get back to the math. Sorry, I'm distracted. All right, so the anatomy of a quadratic graph. Sorry, so quadratic graphs, if you're not familiar, right? These are not linear. These have a different shape. These have a U shape. Okay. And one of the benefits of knowing our ABCs is that if A is positive, then the graphs open up. All right, so it has this U shape. All right, so that's nice. I call these smileys. All right, so this one is a smiley graph. If it opens up, and that means that the vertex, which is this lowest point here, the vertex is the minimum. Means the lowest possible y value, right? The lowest height. All right, so so conversely, right? And this has to do with our functions unit, right? When we reflected things over the x-axis. If a is negative, that's a reflection over the x-axis. And so these U shapes are going to open down. Right, so it looks like this. All right, and so let's see, there we go. Opens down, and these are frownies. Uh-oh, I don't know if frowny is spelled with an EY or just a Y. I guess we'll just go with a Y. I don't know. I'm sure somebody disagrees with me. I don't know. We'll figure it out when we get back. Resist the urge to Google that right now. All right, let's focus on the math and then put a little star by it. Google it later. All right, so we're going to open this down. That means that the vertex is a maximum. All right, there we go. So that's one sort of piece of a graph to understand the pieces. Something else that's really nice about the ABCs is that a lot like the y-intercept of a slope-intercept form, that constant, right? 0 and then whatever the c value is a y-intercept. Or the y-intercept. There's only one y-intercept. Which is kind of nice. X-intercepts are when y is 0, right? And there could be two of those. So for example, it might look like this. All right, this has two x-intercepts here. A is negative, right? Because the vertex is a maximum. So this has two x-intercepts, or we could have something maybe that has one x-intercept. Maybe the vertex just touches the line and comes back up. That's a possibility. And then maybe we could imagine one, since these curve, right? We can imagine one that just misses the x-axis altogether. So let me do a third one, maybe over here. Right, this one turns before it hits the x-axis. So it's possible to have no x-intercepts. Right? They're always going to have a y-intercept because they're always spreading to the left and right infinitely, right? But they do sometimes turn before they hit the x-axis, so they don't always have an x-intercept. And one thing that's kind of neat about that, x-intercepts are a big part of the unit, right? So we're going to study, let's think about this. There are 1, 2, 3, 4. I'm going to say 5 methods for finding the x-intercepts. All right, and so that's going to cover a number of chapters. Initially, we can use our graphing calculators, zoom in, and find something called zeros with our graphing calculators, and that's great, but we are going to learn algebraic methods as well. So let's just go ahead and list them now so you kind of see them coming up. Let's see, the first one, we can use our graphing calculators. That's our first method. And then I think after that, we can solve equations. And that works for some quadratics. Let's see, and then I think in the next unit after that, we're gonna go get into factoring. That's a great quick way for some, but not all, quadratics. And then we have the quadratic formula. And then the last one, it's a kind of an adaptation on solving for x. It's called completing the square. And this works for some. If you took Algebra 1 at the high school, you may not have seen completing the square. I know it shows up in the 8th grade algebra curriculum because they have algebra every single day, so they get to cover a few more things. So if you took 8th grade algebra, awesome, you've seen this before. If not a big deal. We're going to spend time on it. It's a neat trick that allows us to solve for x on ones that don't look like they could be solved for x. All right, so that's just sort of a preview of things to come. The last thing we want to talk about is the axis of symmetry. The axis of symmetry is the vertical line. Oops, can't spell. But you probably knew that. I can spell. I just don't excel at it. All right, it's the vertical line. All right, so x equals something. Right, those are the equations for vertical line. That goes through the vertex, and it's going to cut and cuts graph in half, right? So we've talked about, in geometry, you talk about a lot of different types of symmetry. I think there's rotational symmetry and reflection, and there's another one. I'll think of it later. So this is reflective symmetry, right? So the example in this one that we're looking at right here, this would be my axis of symmetry. It would pass right through my vertex. So they always have an x in common. If we look at these above, this would be an axis of symmetry here, right through the vertex, and it's going to create a mirror image on the left and the right. So if you folded it, it would match up. Awesome. So let's save the last video for the back, and here's the basics of the anatomy of the graph. Hey Noah, I'm just finishing up some work. Okay.